This is Anthony Priscilla doing a little graphing with this trigonometry class. We're graphing sine and cosine today, and we've already seen what the graph of y, something wrong with my pen. The graph of y equals a sine x, and what the graph of y equals a cosine x looks like for the primary period, which is one revolution around the unit circle, 0 to 2 pi. This is where a is a positive number, by the way. The graph would look something like this. I'm graphing it from 0 to 2 pi. 0, let's see, so a is some positive number. Based on my graph here, it looks like it's 2, isn't it? And if each unit is 1, then if each one of these little squares is 1 unit, then yes, a is 2. But here, just for some number a, I'm not specifying what that unit is on the x-axis. We plot 5 key points, which is going to be the starting and stopping points. We say the sine of 0 is 0, the sine of pi is 0, the sine of 2 pi is 0. At pi over 2, sine of pi over 2 is 1, so 1 times a. At 3 pi over 2, sine is negative 1, so a times negative 1. So here's the graph of, very rough graph, of y equals a sine x, and then the graph y equals a cosine x, very similar. I'm going to graph it from 0 to 2 pi. I'm letting one of these little squares be 1/4 of a pi. So right here would be pi over 2, 3 pi over 2. Graphing between a and negative a. Here the cosine of 0 is 1, so it starts up here. Pi over 2, cosine is 0. Now what we're going to do is we're going to graph things in the form, well, we're going to take these graphs and we're going to move them left and right, stretch them vertically, and to demonstrate that, I'm going to try graphing y equals, let's say 3 sine 2x minus pi. Y equals 3 sine 2x minus pi. Well, little terminology. The amplitude is the furthest distance the graph gets from the x-axis. In general, the amplitude, if a is positive, the amplitude would be a is a. What we'll say is the amplitude is the absolute value of this number here. So the amplitude is 3. The period is the distance on the x-axis that's required for one complete cycle of that curve. So 0 to 2 pi for y equals a sine x, the period would just be 2 pi. In general, the period is 2 pi over the coefficient of x. And the coefficient of x here is 2. So the period would just be pi. Now, so instead of it bouncing between 1 and negative 1, or a and negative a, it's bouncing between 3 and negative 3. The distance on the x-axis that's required for it to make one cycle is pi units. Instead of it starting at 0 and stopping at 2 pi, the way we'll find where it starts and stops is you take the angle, that's the stuff that comes after the trig function, and set it between 0 and 2 pi. And just solve this thing for x. Get the x by itself in the middle. So 2 pi plus 1 pi, 3 pi, and then divide by 2. So instead of the graph going from 0 to 2 pi, it's going to make this shape right here. It's going to make that shape, but it's going to be bouncing between 3 and negative 3. And instead of starting at 0 and stopping at 2 pi, it'll start at pi over 2 on the x-axis and end at 3 pi over 2 on the x-axis. So the graph would look something like 1, 2, 3. It's going to be bouncing between 3 and negative 3 on the x-axis, and I'm using 2 blocks for pi over 2, just like I did up here. And so if you can imagine picking up this purple shape, this first point isn't going to be starting at 0 on the x-axis. It's going to start right here at pi over 2. There. So I'm picking up this purple graph here and just moving it down here. And I have to sort of squeeze it in. The second key point is when it's up at 3 and down to there, negative 3. So the shape looks something like that. Now, if we wanted to continue this graph, realize these graphs don't start and stop. All I've done is show one primary interval. This is the interval that would make the angle go from 0 to 2 pi. Now, if you plug pi over 2 in, you're going to get, for x, you get a 0. If you plug 3 pi over 2 in for x, that's where you get 2 pi. So that's what I'll refer to as the primary interval. If we wanted to keep going, it would go from 3 pi over 2 to 5 pi over 2. Just keep adding whatever the period is. So now that's the graph of y equals positive 3 sine 2x minus pi. Let's just briefly discuss what would happen if we were graphing y equals, oh wow, this light switch is sure going off. If we were graphing, oh wait, I don't want that, I want a different color. How about this one? Y equals negative 3 sine 2x minus pi. Well, if you have this, notice up here, I said A was positive number. If A weren't a positive number, if it were negative, then the graph is reflected across the x-axis. So can y'all imagine sort of flipping it across the x-axis? So the green graph that I just drew in is y equals A cosine x, where A is negative. And right here, this one was y equal A sine x, where A is negative. So the graph of y equals negative 3 sine 2x minus pi would be this graph reflects, let's say, is reflected. Oh, let me see. How will I word that? To graph this, Oh, I better move this up a little. To graph y equals negative 3 sine 2x minus pi, you're going to reflect or flip across the x-axis. So if you can graph y equals positive 3 sine 2x minus pi, you can sure graph y equals negative 3 sine 2x minus pi. Once you've done this one, just flip across the x-axis. Now, let's see, what about the graph of y equals 2 plus 3 sine 2x minus pi? Well, this 2 here, what that does is shift the graph up 2 units. So if we needed to graph y equals 2 plus 3 sine 2x minus pi, we graph 3 sine 2x minus pi, and then can you imagine taking each of these points and just shifting it up 2 units? Okay. Now, if this number here were negative, suppose we wanted to graph y equals, can y'all see my orange? Suppose we wanted to graph negative 2 plus 3 sine 2x minus pi, then this negative 2 here would mean that you're shifting it down 2. Sometimes the way you'll see these vertical translations written is at the end, maybe plus 2 or minus 2, which is how I prefer to do it, but it doesn't seem like your book does it like that. Your book usually puts the vertical shift in front. Not always, but usually. Now, some terminology I need to mention up here. The phase shift, that's the horizontal shift. Instead of starting at 0, this graph started at pi over 2. So you could see it written like this. The phase shift was a positive pi over 2. Instead of starting at 0, it started at pi over 2. Or you might see it written in terms of the words right and left. Since it's positive, it was shifted to the right. And if you just want to, if you're told just find the phase shift, it's the 0 that matters. So if you're told to find the phase shift, just take the angle, set it equal to 0, like 2x minus pi, set it to 0, and that'll give you the, solve for x, and that will give you the phase shift. Move the pi, divide by 2. But if you're actually going through graphing it, you're going to find the phase shift. It's going to be over here on this side where there's 0. Okay? So that's graphing sine and cosine curves. And we'll take a break right now. And